And welcome back again. Yes, and then if it's gonna check this code is then gonna print out the left part and then go back and check if the pause right here is equal to null. And if it's not equal to null, we're gonna print out from the code again, and then this time it's gonna see out the pause data of the this number because it should be printed out before this one since it's smaller, and then afterwards this is going to be printed, and then it simply prints out all the numbers from left and then all the way to the rightest number, if you can say so, and then printing out, sorting it that way. And then in order to print out this tree, we simply use print out root down here, and then we also and then we of course run the build tree function all the times, as many times as we have the size array. This function inside the struct in order to build the tree. Yeah, and that's basically the binary tree. And we can just try and run it, and then afterwards take the quick sort. Oh, this is the quick sort. I'm going to show you that afterwards. Initial, we're going to have an array here, which is being sorted like this, and this is the binary sort: 1, 2, 3, 4, 5, 6, 7, 9, and then with a 0 in front. And then, sorry, it's going from 0 to 9, and then it's all of these are going to 0 to 9, which they should, so it works really well. But actually, with binary sort, we didn't put it into a new array. This is just sorted out that way, but I didn't have any more time, sorry. So, but still, we get the idea of how the binary array works. And then I'm going to show you the quicksort. The quicksort is a bit more tricky. And first of all, I would like to say thanks to xoix.net, because most of the code is actually from them, but I understand it. So I'm going to explain it to you how it works. First, we have the partition void code or function, which we're going to run later on in the quicksort function. And inside this quicksort function, we call the code up here, and then we also make a new random number just when we call it, but we're gonna get into that. But as you see, what the quicksort does first, we see how the function starts, and then we say if the size of the partition which we have, let's say the partition is just these 4 numbers. If it were, okay, let's say if it was only one number, it would just return this value for the function, since we don't want to do any if we only have one function left, meaning that this is a partition, we don't have anything to swap with because this is at the right position. So the current partition set on container element is actually at the right place position. So that's what that does. And then we have the step 1, selecting a random pivot in the array. Actually, best is if we have like the mid number of the array, but it's hard to find that one, or at least we didn't do it. So we just gonna take a random array and then hope for the best effective outcome. And then we just simply use an IPA, a random number, and the modulus of the I size. And then this is of course what the pointer array is pointing at. Yeah, I should probably say that we're gonna include an array, a pointer, and a interchange function. So, and then we see how to pivot, so we see what pivot to start from. Then we set the int lower to 0 and the int I upper size to I size -1, meaning that we're going with I lower and I upper. And then we're going to say, well, I lower is less than I upper, meaning the position 0 and last position is not equal to each other, like meeting at the pivot. And we're going to run this code. So while the first number, if if the first number is as long as the first number is less than the pivot. Oh, so yeah, let me just see. It's less than the pivot. The pivot is just gonna we're just gonna proceed to the next number, because then we wanted to get all the small numbers on this side and all the bigger numbers on this side from the pivot. So, but then if we get a bigger value, we are of course gonna keep that one and then swap that with the first lower number from this side, going from right to left, and then we're gonna swap it. And yeah, we're gonna see that later on, and that's pretty easy. So just going through the whole array, finding the first lower or higher number, and then swapping each other down here. Yeah, and that's basically it. But then when we've done all of this, then we should run the code again with the new partition being the IPA, and we're here, and the size of the array being I lower, the position I lower, meaning like this position. So it's gonna be 4 or something, and then we run the function again, taking a new random pivot, and then putting the smaller values over here and the bigger values over here, and then doing it again and again. And then when we only have one value left, we can then use the return. The return is going to be, the return up here is then going to be true again. It's going to run the function, yeah, and then we're going to put them into right places, so it's going to be sorted right. And sorry, it is a bit complicated. And then whenever we don't have any more left sides left, the lower ones, and we're gonna run the function again, but just then from the next partition, which will be, it will probably be somewhere in here in our example, and then run from these, so that we have, so we then start off by sorting the left parts and then going further down and then taking this partition afterwards, and then taking going like this all the time, meaning that we're gonna point at the I lower plus 1, the I lower the number we're ending at, and then plussing it with 1, so here, and then going here, and then of course the size is gonna change of the whole array. So and then we're just, and then we're gonna, I'm gonna show it to you in a bit when we run the code. And then in the main function, we have the array, we have the deployment. I guess we don't need the deployment. No, we don't. Nope. And then we have the array size. Not sure I used it, maybe I just used 10. And then we have some couts. And if we go down to the quick sort, we're just gonna be printing out. Do I actually print the array? I'm not sure I'm gonna do that, but I'm gonna call the function here. So let's try and do it and then see. I wrote a lot of couts so we can see how it works. So first off, we're gonna see the pivot is 8 in this example. That's a bad pivot, I guess. Just gonna try again and the random. So now the pivot is 3. Let's just take 3. And the I lower is 0 and I upper is 9. This one and this one. That's the positions. That's like the range of the array. And the I value is 5, which it is. Oh, we're going to take this. And then the upper value is 0, which is 8. So 5 is the first number higher or equal than pivot 3. I'll pivot it here, and that's right. So this is going to be the first value to swap, and then 0 is the first lower equal than pivot 3. Over here, so they are going to be swapped. And then the next one is 6 is bigger than 3, and 1 is bigger than 3, is less than 3, so they're also going to be swapped. And we proceed this way until we get that we're actually going to look if 3 is higher or equal than 3, and which it not, it isn't, well, it is equal to, and then we have nothing more to swap with, so we have to swap with 3, and then the while loop ends since I lower is no longer than less of lower, which we will see in the while loop over here. So, oh, sorry, yeah. Oh, and then we run the function once again, but just with the new positions, being this one. Yep. And then, as we see now, 3 is actually at the right place where it's supposed to be, over here. And then we have a new position over here, going from 1, 2, 3. And as we do here, we have the new pivot 1, as we see over here, and going from 0 to 2, 0, 1, 2. And then we take this is the first one, 5, 1, and also it is the lower left. 2 is not bigger and smaller than 1, so it's just going to stay in. It's just going to be 1 swap loop 1. And then we're actually going to have 2 positions now, one with only 0 and one with only 2. And then the function runs again, and then we see that the current position set only contains 0 element. This one, we're actually only going to do this one now. And so here it's recursively run. Going to run the function again, only with that one. And then it's gonna be, no, sorry, this is gonna be, this was gray, and then we have 2 positions. Then this one, we're gonna run the function again, just from this part up, and then we see, oh, number 2 also alone, so it's also gonna run again. And then we have the function started again, and then we have again, it's going from 0 to 5, meaning 1, 0, and 0, 1, 2, 3, 4, 5. And then we're just gonna have the pivot in 9, and that's this one, and then we're gonna swap, 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 and then just proceed with this function until it's sorted. And then last up we'll get the sortation. The sort is 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 9, just as we did before. And that's basically how the quicksort works. And I really hope you understood it. But I definitely understand it. It's just a bit difficult to retell. But I hope I did well. So thanks for watching, and see you in the next hand in. Bye.